What is a power pattern? For the best understanding of the topic, power pattern, let us consider an example of a heartbeat pulse. Actually, the actual data of heartbeat of a person is measured through a medical instrument and is represented in the form of a pulse. So we can say that the overall wave of a particular person's heartbeat is the actual pattern in which the heart pumps. Similarly, the overall pattern that is made by considering an antenna is called as a power pattern. Thus, we can say that a graph of the radial component of the pointing vector at a constant radius as a function of angle is called a power pattern. Now we'll discuss in detail the power pattern. For this, let's consider a transmitting antenna in free space, which is represented by a point source radiator. This point source radiator is located at the origin of the coordinates. The overall radiated energy streams from the source in radial lines. Thus, the time rate of energy flow per unit area is the pointing vector or power density. Now we'll discuss it for the point source basically. In point source, the pointing vector S has only a radial component SR with no components in either the theta or phi directions. Thus, the magnitude of the pointing vector or power density is equal to the radial component. Whenever we consider that the overall power pattern formed by a source that radiates uniformly in all directions is an isotropic source. But for such a case, we consider that the SR is independent of theta and phi. If SR is represented in watts per square meter, the graph is an absolute power pattern. Whereas on the other hand, if we consider that if SR is represented in terms of its value in some reference direction, the graph is a relative power pattern. Related terms are